Okay, so if you recall, the work of a spring from 1 to 2 was equal to, work of the spring was minus half ks2 squared minus half ks1 squared. So you can see now the similarities between potential energy and work. Remember that work is defined as something that's happening between 2 points, right? It is how much work is done from point 1 to point 2. And the work of a spring was equal to this. So, okay, so just park this here. Let's look here now. What is the potential energy in a spring? It's called elastic potential energy. It's given by plus half ks squared. And so remember, this refers just to the potential energy at a certain point, whereas the work is the work done between 2 points to move it from one point to the other. The potential energy is just the energy stored in the spring at a certain point. So if you look at the work here, really what you have inside the brackets is you have the potential energy at state 2 and you have the potential energy at state 1. So the work of the spring was the negative of the change in potential energy. Okay, I hope you can get that. Similarly, I know this is elastic potential energy. The work of the weight was the negative of the change in potential energy due to gravity. You just have to take my word for that, okay? Or go and figure it out yourself. Okay, so why is the potential energy in a spring always positive? Okay, so there's two things that can happen. The first is if S is equal to 0, then there's no stretch or no compression, then the potential energy in the spring is 0. Okay, we haven't stored any energy, we can't recover any energy. If we stretch the spring S, okay, plus S even, then the potential energy is half ks squared plus half ks squared, meaning we have stored energy now in the spring, which can then be used by the spring force to do positive work to bring this back to the datum. Okay, if we compress the spring and S is minus S, that minus S becomes S squared, but we still store plus half ks squared. So whether you stretch the spring or you compress it, we are always storing positive potential energy. Okay? So I'm not sure if there's anything else that I need to say over here. But anyways, the point is you can see how the work done is related to the potential energy. That the work is really kind of the change in potential energy in the spring. Work done due to weight is the change in the potential energy. So let's have a look here. If you're at this point, if you move from this point to this point, say this is point 1 and this is point 2, the potential energy at state 1 is 0. So here you would have 0. The potential energy at state 2 is positive. So you would have positive here. So what you would have on the inside of the brackets is a positive number. So the point is the potential energy has increased. It's gone up. But the work done by the spring force was negative. So whenever a conservative force does negative work, it increases the potential energy. Whenever a conservative force does positive work, it decreases the energy, the potential energy. Okay? It is exactly the same with weight. Whenever the weight does negative work, for example, if this box is moved up to there, the weight is acting down, the motion is up. So because these two vectors are opposing, the weight will do negative work, but the potential energy has increased. The potential energy has increased. Whereas, if this box moves down, then the weight will do positive work, but the potential energy the potential energy would be negative. Not negative, the change in potential energy would be negative. Okay, so I hope you're kind of getting the picture here, guys. See you in the next one.